All right, so we have playing shortstop. You pick up a ground ball and throw it to second base. The ball is thrown horizontally with a speed of 18 meters per second directly toward point B. How far were you from the second baseman? And what is the distance of vertical drop going from A to B? All right, so now, what type of problem is this one over here? Hopefully the picture can kind of give you a hint.
Projectile motion.
What is it?
Is it projectile motion?
Yes, exactly. But remember, there are two types of projectile motion. Which one of this one? Which one of those is this?
No launch angle project motion.
Exactly. That means no launch angle or zero launch angle, right? So what you have, you are throwing this with initial velocity of 18 meters per second, where the launch angle theta is 0 degrees. Because see, it says the ball is thrown horizontally. But obviously it's you throw toward this position A, but because of gravity, it's going to change the trajectory, go from there to here. So then, and one thing you know here, it takes 0.54 seconds to go from A to B. Sorry. I know, I guess we can, I usually like to use A at the launch position, but now we have A over there. I don't know, let's use the, like let's say L for the launch for this position. So our point L, that's our point L. All right, so, and what we can do here is this, right? So let's say we can say, all right, given initial velocity is 18 meters per second, then what do we know about projectile problems? What do we know about them?
Acceleration is equal to gravity.
Vertical acceleration equals to negative gravitational acceleration. What else do we know?
Horizontal acceleration?
What is it?
0, right?
Exactly. Horizontal acceleration is 0. And then we're also given time, right? That means the time, we can say the time of the motion is 0.54 seconds. So we want to find, oh, I also forgot, theta initial is 0. And that's extremely important. So how far are you from second baseman? So what are we looking for? What information is that?
We're looking for
Distance.
displacement.
Which displacement? Horizontal or vertical?
Horizontal.
Horizontal.
Horizontal, exactly. Basically, we want to see what is the range, right? This delta X from A, from L to B. So let's say where technically A and B are in the same, horizontal position. We want to know displacement delta X. All right. Now, one thing, if you remember, right, I told you that if you are given the initial velocity and the launch angle, whatever they are, right, first thing you always want to do here is to find the components of the initial velocity. So you want to say initial velocity in X direction is initial velocity cosine of theta, which then will be 18 meters per second times cosine of 0 degrees. Cosine of 0 is 1. That means it's 18 meters per second. Then you find initial velocity in the Y direction. This will be initial velocity sine of theta, theta initial, right? Then will be 18 meters per second, then sine of 0 degrees. And if you hopefully remember, sine of 0 is 0. So there is no initial vertical velocity if your object thrown horizontally. That means in a projectile problem where launch angle is 0, there is no initial vertical velocity. Okay. Now, what I have is this. Doing this, I calculated what's my horizontal velocity. But remember, I calculated that horizontal velocity for position L. But what is my horizontal velocity for position B? Do I have that information? All right, so I think Marina, you told me, Marina Felix, you told me that this is 0, right?
Yes.
So if that is 0, then what is my horizontal velocity anytime later?
0.
The velocity is going to be the same as the
The
initial.
same.
It will be the same, right? Because if I calculate initially to be 18 meters per second, but there is no acceleration, that means it will always be 18 meters per second.
Yes, yes.
And remember, this then means that I can use the uniform motion equation for the x direction. Where delta x is equals to Vx times time. And that's it, right? See, I have time. I just calculated my x velocity, and that's all I need. 18 meters per second, then times 0.54 seconds. Because I know it takes 0.54 seconds to go from L to V. All right, 18 times 0.54, I get delta x of 9.72 meters. There you go, that's part A. Any questions on this?
Yeah, what was that formula that you just used?
Remember, this is this equation, right? Delta x is equals to initial velocity times time plus 1/2 acceleration in the x direction square. You guys remember this equation? Which is
So
a
you're
kinematic
just
equation, right?
you're just shortening it.
Yeah, we're just saying there's no acceleration there, right?
Okay.
So that means this becomes that, and we're saying initial velocity in x is same as final velocity in x. That means it's just Vx. Because initial velocity is the same as final velocity, that means it's always the same. So we can just replace it like that. Yeah, that means because that's the thing, right? Because we know that there is no acceleration there, this equation just becomes that. All right, so part B, it says, what is the distance of vertical drop from A to B? That means what are we trying to find?
Final position of B of Y.
Final.
Exactly. What we want to find, well, what we want to find here is what is the height difference between A and B, right? Because see, my position L, vertical position L of A are exactly the same, right? That means what I want to do here is I want to find that, you know, displacement delta Y.
The final distance between A and B, right?
Exactly. So what is my delta Y? All right. So now, what I have here is everything is given right here in the table. Given that I know my initial velocity in the y direction, remember, is 0. I know the time, I know the acceleration. Which equation can give me that delta y? Which kinematic equation can give me that delta y?
Second.
Second equation, excellent. Delta y is equals to initial velocity in the y direction times time minus 1/2 gt squared.
Yes.
What I have here is this is 0, which makes my life much easier. That means my displacement is equals to just negative 1/2 times g times time squared. 1/2 times 9.8 times 0.54 seconds squared. Negative. All right, so my delta y is then negative 1.4 1.4 meters. Let me put it like that. All right. So what do you guys think? Is negative there? Is it a mistake from my end? Did I make a mistake by having it negative?
No.
Why
No,
is there a negative there?
I
because
was gonna
Dropping.
ask.
What is it? I'm
it's on the x-axis.
Going down, like the ball's going down.
Exactly, because ball is going down, right? I mean, from where you start, you're going down, which is in your negative direction. So you have a negative displacement, and that's why you have that. That means you're going down by 1.4 meters. So that negative represents that. So that don't Don't just make that negative disappear. Sometimes I see students kind of like have negative here, but kind of like ignore that negative in the next part of the equation. All the negatives are very, very important because they tell you in which direction you are changing your position.